बिस्मिल्लाहिर्रहमानिर्रहीम। तो आज हमारा जो क्लास है so far as the NMR spectroscopy is concerned, it is the 1H NMR signals. Last class में हमने कुछ molecules को लिया था and then we tried to understand how many types of signals a molecule will give in the NMR spectrum. उसके बाद में we started with, उसमें थोड़ा ये भी हम कंसिडर कर रहे थे कि छोटे मोटे अंदाज में कि उस सिग्नल एक NMR स्पेक्ट्रम में कौन से साइड में आएगी, whether शील्डेड और डिशील्डेड. फॉर दैट मैंने एक स्पेक्ट्रम को रफली बनाया था यहाँ पे. दिस इज अ टिपिकल NMR स्पेक्ट्रम. दिस इज योर इंटेंसिटी. दिस पीक इज फॉर TMS, which is the standard. For this the delta value is 0, highly shielded. So this is 0. This is the intensity of the peak. This is 2. This is 4. This is your 6. This is 8. Exactly जो कल वाला लेक्चर है. If you have missed that, please follow that part number 1 of this. So this is 9 and this is 10. Scale जो होती है 1H के लिए almost it's from 0, 10, 12. This carbon 13 के लिए this is around 200 and so on. So this is your, this scale is delta, that's chemical shift. It is in parts per million. फिर मैंने बोला था अगर पीक इस एरिया में आता है around 3, 4. This is called as shielding region, shielded peak. And this is also called as upfield condition. Upfield. But ये वाला region is 6, 7, 8, 9, 10 ये वाले side में. So in general we call this as, it is disshielded. It's called downfield condition. So upfield and downfield condition. तो हमने बहुत सारे molecules लिए थे to take some more molecules today so as to finish this. Because इससे अक्सर क्वेश्चन आता रहता है. सो टेक मॉलिक्यूल नंबर 1. आज हम कुछ एरोमेटिक देखेंगे और कुछ जो पाई कॉन्जुगेटेड मॉलिक्यूल्स है अक्सर. जैसे वी हैव अ मॉलिक्यूल लाइक दिस. नाउ दिस इज योर CH3 here. This is one more CH3 and then we have C triple bond N. So your nitrile group here. So your 2 pi bonds. Now इसमें कितने पीक्स आएंगे? अब यहाँ प्रोटॉन है, यहाँ प्रोटॉन्स. अब ये कार्बन this CH3 is attached to this carbon. This CH3 is attached to this carbon. So that means these are equivalent carbons. So इनकी वजह से that's one peak. Now this is hydrogenated this carbon. This is second peak और कोई नहीं. So we have 2 signals here. So 2 signals. अब इनमें हाईली डिस्टिलेटेड कौन है? इट इज अटैच्ड टू द कार्बन व्हिच हैज अ पाई बॉन्ड हियर. मैंने कहा जो पाई बॉन्डेड कंपाउंड्स है यूजुअली अल्कीन और एरोमेटिक. फिर मैं बेंजीन को. एस्टिलीन में थोड़ा सा केस डिफरेंट है, उसमें ओरिएंटेशन पे डिपेंड करता है, वो हम इंशाल्लाह सेपरेटली पढ़ेंगे. और एस्टिलीन का केस इट ट्रिपल बॉन्ड. बट इन दिस केस वी हैव पाई बॉन्ड. इट अटैच्ड द पाई बॉन्डेड वन, सो इट इज हाईली डिस्टिलेटेड दिस प्रोटॉन. So they are shielded. So that means we have 2 signals. So this proton will get value A, that means disshielded. They are higher delta value. So these signals will get B. So in B we have 6 protons. In this A we have 1 proton. So that means B will occur towards this region and it will be tall because 6 protons, and A will occur towards this region and it will be short because it's a single proton. तो मैं अभी मोटे अंदाज में बोल रहा हूँ कि ये बेसिक्स है कि हम कैसे स्ट्रक्चर निकाल सकते हैं. उसके बाद हम लोग वन मोर मॉलिक्यूल लाइक लेट अस सी वी हैव another alkene type molecule. तो ये एक अल्कीन मॉलिक्यूल है. इसमें वी हैव these protons on the double bond. अगर देखिए it's a plane, इसमें molecular polarity है. You can cut this molecule into 2 equal halves across this plane, इस plane से. So that means this part becomes this part. मैंने कहा whenever you have a plane in the molecule, या कहीं से भी अगर molecule को 2 हिस्सों में डिवाइड कर सकते हो. ये बेसिकली सिमेट्री का एक टॉपिक है, पर यहाँ पे इसके साथ हम डील नहीं करेंगे. You can just think that अगर आपके पास मॉलिक्यूल कोई ऐसा ऑप्शन है, you can cut the molecule into equal parts, then you can look up the NMR of one molecule. Now this is CH3, this is 1. So this is one type of proton, this is another type of proton. Now as this is attached to ethylene bond, pi bond directly, so this will get the highly shielded as A and this will get B. So there are the 2 signals in this molecule, A and B. Up because this A, this and this is same, and this is same, तो इसका हम देखेंगे ए में हमें आएंगे 2 प्रोटॉन्स आफ्टर इंटीग्रेशन, इसमें आएंगे हमें 6 प्रोटॉन्स. सो दिस इज अबाउट दिस सेकंड टाइप ऑफ मॉलिक्यूल. सो विल टेक सम मोर मॉलिक्यूल्स फॉर बेटर अंडरस्टैंडिंग. नाउ विल टेक सम एरोमेटिक मॉलिक्यूल. सो मैंने कल कहा था कि टुडेज लेक्चर में विल मेनली डील विथ पाई बॉन्डेड सिस्टम्स. याद रहे कि एरोमेटिक रिंग के साथ जो प्रोटॉन्स होते हैं इथिलीन बॉन्ड के साथ, दे आर डिशील्डेड. This we'll discuss later. This is our benzene molecule. Now we have 1 proton here, 1 here, so there are 6 protons. अब देखिए, you can cut this molecule anyway. अब इसे भी 2 हाउस में उसको कट कर सकते हो, ऐसे भी 2 हाउस में कट कर सकते हो. अब क्वेश्चन यहाँ पे आता है, व्हाट डू मीन बाय दैट. देखो ये कार्बन, दिस इज इक्वल टू दिस कार्बन, क्योंकि दिस बॉन्ड्स, दिस वी हैव अ पाई, this resonance here. So that each and every every carbon is equal. So the protons attached are equivalent. That means these all protons are equivalent. So there are a lot of symmetry options here. So that means we have a single signal for this, 1 signal in benzene. Fine. Now I will take a molecule and replace this by some group. Let us say CH3. Now let us say this is CH3. So we'll make a molecule. Bond to टेढ़ा हो गया. Anyhow, this is CH3. Now we have replaced one of the protons. We have 1 proton here. One मैं दिखाऊंगा नहीं वो. 1 proton here. Benzene, there are 6 protons. So one of the protons have been replaced by CH3. So now we have these type of protons here, one side, and one is from this here. The question is how many group signals are there? वहाँ हमें देखना होता है कि यहाँ methyl group is electron donating group. Fine. So it will donate the electron density here. Now electron density, if we have donating group in the ring, then we have ortho position here. Concept of ortho position. This is meta position. This is para. This is also meta. This is also, this is meta. This is ortho. So we have 1 para position, 2 meta. Meta positions are equal. ये यहाँ से equal distance from here, this carbon. So meta positions are equivalent. The protons are this, they are equivalent. Protons are this, they are equivalent. They are equal. That means there should be 1, 2, 3. Ideally there should be 4 signals. Ideally. हमारा जो concept हमको बोलता है. But that's not the case. Practically you observed only 2 signals. These 5 protons are giving 1 signal, and this methyl group, that's the 3 protons, that give 1 signal. So you get 2 signals in the spectrum. Why is that? क्योंकि ये जो methyl group है, it's a weakly electron donating. Now this is the question. अगर group attached to the ring is strong donating or withdrawing, then we have those ortho meta para positions. फिर वहाँ पे protons will behave in a different manner. But इसका effect is very weak, so they all have almost, they are equivalent. So you'll get 1 signal for this usually, and you will get 1 signal for this. So okay, 2 signals, you will not get 4 signals normally. So you get 2 signals normally. If it is very very high resolution type of things, then it's possible. अब यहाँ पे so these protons are directly attached to the ring. मैंने कहा कि ring से जो protons attached होते हैं या double bond के साथ जो protons attached होते हैं, they are highly deshielded. ठीक? So that means these will get A, these 5 protons, and these 3 protons will be B. That means this is towards the dishielding region and this is towards the shielding region. Okay. So an important example. Now we'll take the example of nitrobenzene. तो ये एग्जाम्पल्स आप बुक पे लिख सकते हो. यू कैन मेक द नोट्स. मैंने जितने भी टॉपिक्स रिकॉर्ड किए, प्लीज मेक द नोट्स. दैट विल वेरी यूजफुल फॉर एनी ऑब्जेक्टिव एग्जाम. ये क्वेश्चंस तो बड़े एग्जाम्स में भी आते रहते हैं कॉम्पिटिटिव. नाउ वी हैव द एग्जाम्पल लाइक now we have a group called as nitrobenzene. So a nitro group, now one of the protons has been replaced by nitro group. Now nitro group is electron withdrawing. That means we have here less electron density. That's plus. I'll show it plus. This will become electron rich. We know donating के case में ortho positions and para positions are electron rich. So and withdrawing group के केस में we have these electron positions, that's ortho and para there. Electron deficient, I'm showing plus. So this is ortho, this is meta, this is para. Same is the case, meta on this side, same. So this is your ortho, there's no proton, there's no proton. So now this is a very strong electron withdrawing, so these are different types of protons, different. So meta protons, two types of meta protons are there. Ortho, two types of ortho protons are there. And one para proton is there. So that means you have three signals. Nitrobenzene will give three signals. Three signals in nitrobenzene. Now, इनमें से कौन सी डिशील्ड होगी? मैंने कहा जहां पे इलेक्ट्रॉन डेंसिटी कम होगी, बिकॉज यहाँ पे इलेक्ट्रॉन डेंसिटी कम है, इट विल बी हाईली डिशील्डेड. यहाँ पे इलेक्ट्रॉन डेंसिटी कम है, पर इसकी डिस्टेंस यहाँ से बहुत ज्यादा दूर है. So this is A, this will get B, and this is C. So this is the condition of protons. क्योंकि aromatic protons है, they will be all deshielded, but deshielding के केस में this will be more deshielded followed by this, followed by this. So this is the case of electron withdrawing groups. Now, the example of one more benzene derivative. अब इस टाइप का मॉलिक्यूल है तो बेस्ट ये लगता है सिमेट्रिकल, तो आप इसे ऐसे भी काट सकते हो, ऐसे भी काट सकते हो, टू प्लेन्स. मैं थोड़ा सा इसको इजी वे में एक्सप्लेन, नॉट गोइंग इनटू द एलिमेंट्स ऑफ सिमेट्री, क्योंकि आप लोगों का उसको कॉन्सेप्ट नहीं है. जब आपकी सिमेट्री है देन आप एक साइड कर लीजिए, सो आप इसे भी देख सकते हो. द बेस्ट वे कैन गो दिस वे. सो वी हैव CH3 ऑन दिस साइड, सो वी हैव वन प्रोटॉन हियर एंड वन हियर, और in the next half. They will become equivalent because they are equidistant from here. So one set of protons here, one set of protons here. So you have overall two signals in the NMR. And now they are directly attached to the ring, they are highly deshielded, they will get A, and the CH3 type proton that will get B. So A and B. A means highly deshielded followed by B. One more example. Okay. Now we'll take example of symmetrical molecule. This is, you call it Xylene. Fine. अब देखिए ये सिमेट्रिकल मॉलिक्यूल, ऐसे भी इसको ब्रेक कर सकते हैं टू इक्वल पार्ट्स. यहाँ से भी आप प्लेन लेके इसको डिवाइड टू इक्वल पार्ट्स, यहाँ से भी कैन ब्रेक टू सिमेट्रिकल मॉलिक्यूल ऑल. अब इसमें ये जो प्रोटॉन्स रिंग के साथ है दे आर ऑल इक्वलेंट, ये while as ये दूसरे टाइप के प्रोटॉन्स they are equivalent. So you'll get two signals, one signal for methyl group protons and one signal for the protons at the ring. ठीक, so two signals. Again जो ring के साथ directly attached they will be deshielded, they will get A, while as जो ये CH3 वाले proton will get B. So this is A means highly deshielded, then followed by B which is less deshielded or which are shielded. Okay, so one more example. More example. Aromatic ring, CH2 and the CH3. अब देखिए CH3 बहुत, उसके बाद CH2, इनका नेचर दे आर डिफरेंट है, तो दिस डिफरेंट टाइप ऑफ प्रोटॉन्स, डिफरेंट टाइप ऑफ प्रोटॉन. अब यहाँ पे so one protons here, one here, one here, one here, one here. There are 5 protons in the ring. Fine, 5 protons. अब यहाँ alkyl group है, जैसे मैंने अभी कहा था एग्जाम्पल है methyl group, the weak electron donating. Same is the case the alkyl group. It's a weak electron donating. तो इनका नेचर में ज्यादा फर्क नहीं पड़ेगा. तो all these 5 protons in the ring, that we have one type of protons. So we have 1, 2, and 3 signals in this type of compound. Now those which are in the ring, they are highly deshielded, they will get A. Close to the ring, that's here, that's B. So this proton will get C. Highly deshielded followed by B, followed by C. That means they are more towards shielding region. That means they are towards this region. So this is ring protons, then CH2, then towards CH3. तो बहुत आसान है, ज़्यादा मुश्किल नहीं है. So we have done many number of examples. So we have one more example, I think, and then we'll stop. I think we have done enough examples. इसमें से ज़्यादा question आएंगे नहीं वैसे. If I could get one more example. I don't know if I can get one more example here. Somehow. Let's get some example here. I'm searching some interesting example. So if you have, let us say, ethanol. Ethanol was the first molecule, was actually solid through NMR spectroscopy. CH3, CH2. So normally, ethanol we'll discuss later because it's a special case. The number of peaks in the ethanol depends on the solvent and the impurity in the solvent. So we'll record a lecture on this ethanol. So it'll be me. So we'll record a lecture on the ethanol and the effect of impurity on the NMR spectrum, because इसमें थोड़ा OH gets exchanged. So please do follow us. We will definitely upload a lecture on the ethanol. So that's not a good example. If I can take so normally, because cases for spatial बन जाती है ना, we are not in a position to solve that. फिर हमें पहले factors पढ़नी है, उसके बाद ही you can take those examples. We can get some simple example. Okay, yeah, it's a very good example. ये ड्रग्स में भी आती रहती है अक्सर example. Just making benzene here. Painting is very, very bad. This is a molecule called as stibline. It's called as cis-stibline, कि ये दोनों साइड में आओ. इसमें ऐसे आप कट कर सकते हो to two halves, ठीक? So this is one type of proton and this is another type of proton. You got two signals here. So cis-stibline, very important. अक्सर entrance में भी आता रहता है और lectureship exams or the net exams sometimes related derivatives. Cis-stibline, take the cis compound of this stibline. So stibline is STIB. So you have two signals. अब इनमें चूंकि aromatic protons जो है, they are highly deshielded followed by this. So this will get A, these aromatic protons. जिनका number है 5 plus 5, and this is B, the number is 2. So you have A and this is B. That means highly deshielded followed by B. Now अगर हम इसका cis stibline बना लें, cis form. Okay, make cis form a bit. ये बेसिकली सिमेट्री का कॉन्सेप्ट है. यहाँ पे शायद इस लेवल पे शायद ठीक नहीं रहेगा डिस्कस करना. मे बी अगर फैक्टर्स का कोई टॉपिक होगा सिलेबस में तो विल डिस्कस देयर स्लाइटली. हमें थोड़ा टीडे बन रहे हैं सब. Anybody can understand. This is one more. Now is this molecule symmetric? प्लेन तो नहीं लग रहा है इसमें, but one thing is there. इसको हम रोटेट कर सकते. Their center of symmetry. If you move from this point equidistant to this distance equally, then you'll get the same group. You'll move in this side, you'll get the same group. This is called as center of symmetry. Then this is also it's called a rotational. If you rotate this molecule, you can equally end up with this. After 180, you will end up with a similar type of molecule configuration. So इसमें basically this the center of ये जो है क्या हम बोलते हैं इसे axis of symmetry. वो वाले cases में there was it's called plane of symmetry. So this is called axis. You can rotate through past the axis and then rotate this molecule 180. You'll get same molecule back. So बोलते हैं rotational element of symmetry. तो इसमें भी symmetry है तो you'll end up with two peaks. One the aromatic peak and one this. So two signals in this. Two signals. So this is A for this and B for this. So it's because it has that element of symmetry which is axis of rotation, and the cis-stibline you have element of symmetry that is plane of symmetry. You can cut this into two equal halves. I think these are enough examples for your level, and then we'll see if there's a topic regarding the factors affecting the NMR spectrum. There we'll get some better examples also. I hope this is enough. So if you have any example, please write to me, you can go back. That's all for that.